Hello, welcome back to our channel. Today we are going to discuss about gravitation short answer questions. It is very important for board exams for both the TS and AP. And in this first short answer question is the Kepler's law. See, Kepler's law is very interesting. The first person who given that about the planets and Earth, that moment is Kepler's, and he given how many laws? There are 3 Kepler's laws. First one is the law of orbit, second one is the law of areas, and third one is the law of time periods. What is the law of orbits? First one is the law of orbits. All planets are revolving around the sun in elliptical path. See, this is the all planets are revolving around the sun in elliptical path. But where is the sun? At any one foci. See, either here or here we can observe the sun. This is called the focus, but here 2 are there, that's why this is called the foci. And just you should remember that all planets are revolving around the sun in elliptical path. This is called the law of orbits. Very simple. Then second one is the law of areas. Law of areas means it covers equal areas in equal intervals of time. See, this is the elliptical path, and here planets are moving. Suppose one planet is moving from here to here. This area is A1 and this area is also A2. Suppose this is 100 meters square, this is also 100 meters square. A1 equals to A2. If it is taking 1 hour, same 1 hour it will take like that. So it covers equal areas in equal intervals of time. That is called the law of areas. This is called the Kepler's second law. Then what is Kepler's third law? Kepler's third law is called the law of time periods. See, this is the major axis and this is the minor axis. Semi-major axis means we can take half of this one. This is represented by A. So the law of time periods is law of time periods. He given that relation. Square of the time period is directly proportional to cube of the semi-major axis. Square of the time period is directly proportional to cube of the semi-major axis. Don't confuse. This is the semi-major axis. We are represented by A. This is called the Kepler's laws. First one, law of orbits. All planets are revolving around the sun in elliptical path. So position of the sun is here. Then second one is the law of areas. It covers equal areas in equal intervals of time. Then law of time periods is the square of the time period of that particular planet is directly proportional to the cube of the semi-major axis. Then come to our second one, relation between small g and capital G. Here what is small g and what is capital G? You know that small g is called the acceleration due to gravity and capital G is called the universal gravitational constant. And relation between them, how to find out? Particularly they are asking if the body is on the surface of the earth. Look here, very easy. This is the earth. It is having the spherical shape. Mass of the earth is, we can take it capital M. This is the radius of the earth, capital R. Now where you are, you think you are here. Mass of your body is M. You know that on the earth every body is attracting towards the center of the earth. That is nothing but weight of the body. We can say that F equals to mass into acceleration due to gravity. But from Newton's law of gravitation, between two massive bodies, attractive force is acting. What is that force? F equals to GMM. See, this is the weight of the body and this is the gravitational force, GMM by distance square. Here distance is R square, but F equals to Fg. Instead of F we are writing mass into acceleration due to gravity, and this is the GMM by R square. This mm cancel. Now we got it. Relation between small g and capital G is the G equals to Gm by R square. From this we can find out the relation. But always G is variable, but acceleration due to gravity is constant. Look here. See, weight is mg, gravitational force is gmm by r square. but these two are equal after simplification. This is the relation between small g and capital G. Then our third short answer question is variation of g with altitude. Height is, that formula is gh equals to g into 1 minus 2h by r. Don't confuse. When we are going to certain height, how to calculate the acceleration due to gravity with the help of this expression. So like that, when we are going inside the depth, like inside the mines, then that the acceleration due to gravity gd equals to g into 1 minus d by r. But the question is, you are going same height and same depth, in which case acceleration, what about the acceleration due to gravity? You remember that in this expression, this is minus 2h by r. Here h is same and d is also same. 2 times we are subtracting. Here also 1 time we are subtracting. So when we are going using the same height, that to less heights and less depth, we can remember that gh is less than gd. More decrease in acceleration due to gravity when we are using the certain height. Suppose for larger heights, we can observe that reverse. You should remember that gh is greater than gd. Then our fourth short answer question is, what is the orbital velocity? What is the orbital velocity? Very, very important. Mostly from this chapter, the important questions are escape velocity, orbital velocity, geostationary satellite. But now we are going to discuss about fourth one is the orbital velocity. Fourth short answer question is, what is orbital velocity, and derive the expression for this. The definition is the minimum velocity, the minimum horizontal velocity required to revolve around the planet. It may be Earth, it may be Mars, it may be that another like Jupiter. So we require minimum horizontal velocity, that is called the particular planet orbital velocity. Means that is revolving around that planet in circular path. So it is having which force? Centripetal force. So whenever the body is having the circular motion, you can say that is having the centripetal force. But you remember that centripetal force is not the basic force. It is provided by any basic force, either gravitational force, electromagnetic force, or strong and weak nuclear forces. But don't go that much depth. You should remember this here. Here the height of this one, we can take it h. So from the center of the earth to here, r plus h. Mass of the m is the mass of the earth. M is the mass of the earth, and r is the radius of the earth. Radius of the earth. We know that how much gravitational force is acting. Here the mass of the body is m, small m. From the Newton's law of gravitation, F equals to g m by r plus h whole square. But here it is having the centripetal force, mv0 square by r plus h. Just now I said centripetal force is provided by the gravitational force, means we can take it F equals to Fc, or Fc equals to F. mv0 square by r plus h is equals to gmm by r plus h whole square, which is cancelled. This one cancelled, small m cancelled. V0 equals to square, when we are removing, we are getting under root gm by r plus h. Till here you are writing, you will get the marks, don't worry about it. If you want to go through the small extension also, you can use that expression is what? Look, if h is very, very less than r, instead of r plus h, we are taking approximately r only. Then how you are getting this expression? V0 equals to under root gm by r. But just now in that second S.A.Q, relation between small g and capital G is g equals to gm by r square. Instead of gm by r, we are writing gr. Look here, orbital velocity depends only on the radius of the planet. Depth does not depend on the mass of that one. And here you remember that relation is g equals to gm by r square, means r into r. From this gm by r is how much? Small g into r. So instead of gm by r, I have written gr. Then our fourth short answer question is, what is escape velocity? It's very interesting. Suppose we want to escape from the earth. Is it possible? without rocket? No, it's not possible. Why? We require minimum vertical velocity to escape from the planet. That is called the escape velocity. And escape velocity of the earth is 11.2 kilometers per second. So per second we are having minimum velocity how much? 11.2 kmph. Kilometers per second, not per hour. Look here. Anyway, our next question is escape velocity. And derive the expression for this V. For this also we should consider, look, this is the earth. Mass of the earth is m, radius of the earth is r. But we are going from here to here, certain height h. Then from here to here the distance is r plus h, and mass of the body is small. Here the body is moving away from this, so potential energy is converting into kinetic energy. From the law of conservation of energy, here potential energy is converting into kinetic energy, means both are equal, but both are acting in opposite direction. Just to remember that kinetic energy of this body is Ke equals to half mv square, means escape velocity square. Then potential energy, gravitational potential energy equals to minus gmm by r plus h. But from law of conservation of energy, what we are writing here? Ke equals to minus potential energy. Ke equals to minus potential energy. So half into mv square. Here already minus is there, so minus into minus plus gmm by r plus h, which is cancel, cancel. You are getting v square equals to 2gm by r plus h. Then v equals to under root 2gm by r plus h. Till here also we can write it, you will get the mass. Some materials we can extend little bit also, see. But when h is very less than r, you know that radius of the earth is 6400 kilometers, but we can use only 100 kilometers, means instead of r plus h we can take it only r when small heights we are taking. Then v equals to under root 2gm by r. Just now you know that instead of gm by r we should write it 2gr also. And v equals to 11.2 kilometers per second. When we are substituting g value is 9.8, r value is 6400 kilometers, you can remember that value is 11.2 kilometers per second. See, think 1 second we have to cover 11.2 kilometers, then only we can escape from the earth. Then our next question is very easy and very interesting also. What is the geostationary satellite and what are the uses for that? Geo means like earth only. What is the time period of the earth? How much time it will take to revolve around it? 24 hours. So if any satellite, the time period is equals to Earth's time period 24 hours, you can say that is called the geostationary satellite. So that satellite is revolving around the earth. And what is the use of this one? Why it is revolving? It is not revolving like not for a time pass purpose. We need the information. See, these days and from many years onwards, our people are sending the satellites. Sometimes they are saying that it gives the information about the weather. It gives the information about the minerals. It gives the information about the roads. It gives the information about the communication system. See how many ways we are using that geostationary satellite. So first of all, the definition is the satellite whose time period is equal to time period of the earth. That is called the geostationary satellite. Then what are the uses of this one? It can give the information about the weather, forecasting of the weather, and it gives the sending the TV programs, and that one communication system we are using that one. Suppose any cyclones are there, like a tsunami is there, any structure is changing in that one, it gives the information of not only that one. So very well, like in communication, weather, any minerals, any changes, everything we can get the information with the help of the geostationary satellite. Remaining short answers are very simple. Seventh question is, if two places are at the same height, then one is at sea level and another one is on mountain. See, we are at sea level, same height, like 100 kilometers or 100 meters also you can take, and we are using that mountain also, where we should observe the more acceleration due to gravity. See, suppose we are using, you know that what is the relation between small g and capital G? G equals to gm by r square. But here we are using, suppose the height is h, r plus h whole square. But here same height, at this sea level we are using same height, and on the mountain we are climbing that mountain also same height. So which is constant? This is constant. So G is directly proportional to mass. Where we should observe the mass? Mountains. On the mountains, that mass is more. Sea level means air is there. So where we should observe the maximum acceleration due to gravity? In which case, on the mountains we can observe the more acceleration due to gravity. Then our eighth question is, you should remember that the weight of an object is more at the poles than the equator. At which of these we can get more sugar? More sugar for the same weight. Look here, it's very interesting. You remember that variation of G, with height we have completed, with depth also you know the expression. Now latitude means with respect to angle. See, G phi equals to G into 1 minus r omega square cos square phi. So with respect to angle, that is changing. At poles phi equals to how much? 90 degrees. Cos 90 is 0. We are getting G phi equals to G. 9.8 meter per second square we are taking, maximum it is. Like that at equator, no need of writing this expression, for just understanding I am giving this. So at equator G phi equals to 0 degrees. You can get it, G phi equals to G into 1 minus r omega square. So this is minus this one, means always you remember that this is at poles and this is at equator. G poles is greater than acceleration due to gravity at equator. But you know that weight, what is the formula? Mass into acceleration due to gravity. There is no change in the mass because mass is the quantity of matter. So G value is more at poles, then G value is less at equator. So we can get more sugar at the equator. Then our ninth question also, listen, very interesting question all this. If a nut becomes loose and gets detached from a satellite. See, just you should imagine that one satellite is revolving around the earth. From that one nut becomes to loose and detached from that. The question is, will it fall down to the earth or will it revolve around the earth? Whenever it is detached from that, look here, suppose that satellite is having some velocity to revolve. When it is coming from that, it is also having the same velocity also, no? So nut is not coming to the earth, it is also revolving around the earth, like whatever the satellite is revolving. Then our next question, and that is the last one. An object projected with a velocity greater than or equals to 11.2 kilometers per second, will it return to the earth? Think, just now we discussed about escape velocity of the earth is how much? 11.2 kilometers per second. Whenever we are taking one stone, rocket only, not stone, it is not possible. So we are sending the rockets. Why? That velocity is more than 11.2 kilometers. They never come back. Permanently they are escaping from the gravitational force. So in this case the answer is, it is not coming back. Permanently it is escaped from the earth. Thank you everyone. Please subscribe my channel, and further S.A.Qs also you can follow from the Rishit physics classes playlist. Already that motion in a straight line, motion in a plane, and gravitation, thermodynamics chapters are there. Thank you everyone. Please subscribe my channel.